In this video, we are going to test the Ryzen 7 7800X 3D processor with an infrared camera and see how hot it gets under load. But before we do that, let's take a moment to explain what is the Ryzen 7 7800X 3D processor and what are its main features and specifications. The Ryzen 7 7800X 3D is one of the latest gaming processors from AMD, released in April 2023. It is part of the Ryzen 7000 series, which is based on the new Zen 4 architecture and the 5nm process. The Ryzen 7 7800X 3D has 8 cores and 16 threads, with a base clock speed of 4.2 GHz and a maximum boost clock frequency of 5.0 GHz. It has a TDP of 120W and supports DDR5 memory and PCIe 5.0. But what makes the Ryzen 7 7800X 3D special is its 3D vertical cache technology, or 3D V-cache for short. This technology allows AMD to stack an additional layer of L3 cache on top of the CPU chiplet, using through-silicon vias, TSVs, to connect them. This increases the L3 cache capacity from 32 MB to a whopping 96 MB per chiplet, which means the Ryzen 7 7800X 3D has a total of 104 MB of cache, including L2 cache. Why is this important for gaming? Well, cache is a fast memory that stores frequently accessed data and instructions, reducing the latency and bandwidth required to access the main memory. Having more cache means that the CPU can handle more complex and dynamic game scenarios without slowing down or stuttering. AMD claims that the 3D V-cache technology can boost gaming performance by up to 25% on average, and even more in some titles. The Ryzen 7 7800X 3D is also compatible with the new AM5 platform, which brings several advantages over the previous AM4 platform. For example, AM5 supports DDR5 memory, which offers higher speeds and lower power consumption than DDR4 memory. AM5 also supports PCIe 5.0, which doubles the bandwidth of PCIe 4.0 and enables faster communication between the CPU and other components, such as graphics cards, SSDs, and network adapters. The Ryzen 7 7800X 3D is priced at $449, which makes it a very attractive option for gamers who want the best performance possible without breaking the bank. It competes directly with Intel's Core i9-13900K, which is also an 8-core/16-thread processor with a similar clock speed and TDP, but costs $580. The Ryzen 7 7800X 3D also beats AMD's own Ryzen 9 7950X 3D, which is a 16-core/32-thread processor that costs $699, but has lower gaming performance due to its lower clock speed and larger cache latency. So, now that we have covered what is the Ryzen 7 7800X 3D processor and what are its main features and specifications, let's move on to the main event, testing it with an infrared camera and seeing how hot it gets under load. Stay tuned for the next section. In this section, I'm going to show you how I set up the infrared camera and the testing environment to measure the temperature of the Ryzen 7 7800X 3D processor under different workloads and scenarios. The infrared camera I'm using is the MLX90640, which is a 768 pixel, 24 by 32 thermal camera that can detect the infrared radiation emitted by objects. I connected this camera to a Raspberry Pi computer, which will be used to capture and display the thermal images of the processor. To mount the camera on the processor, I used a custom-made bracket that holds the camera at a fixed distance and angle from the processor surface. The bracket also has a hole for a thermocouple probe, which will measure the actual temperature of the processor as a reference. The testing environment consists of a desktop PC with the Ryzen 7 7800X 3D processor installed on a compatible motherboard. The processor has a stock cooler and thermal paste applied on it. The PC is running Windows 10 and has various software tools for monitoring and stressing the processor. To measure the temperature of the processor under different workloads and scenarios, I use the following steps. 1. I turned on the PC and let it idle for 10 minutes to reach a stable temperature. 2. I started the Raspberry Pi and launched the thermal imaging software that displays the thermal image of the processor on a monitor. 3. I recorded the thermal image and the thermocouple reading of the processor at idle state. 4. I launched a CPU benchmark software on the PC and ran a single-threaded test to stress one core of the processor. 5. I recorded the thermal image and the thermocouple reading of the processor at single-core load state. 6. I repeated step 4 with a multi-threaded test to stress all cores of the processor. 7. I recorded the thermal image and the thermocouple reading of the processor at multi-core load state. 8. I turned off the CPU benchmark software and launched a gaming software on the PC to simulate a realistic scenario of gaming load on the processor. 9. I recorded the thermal image and the thermocouple reading of the processor at gaming load state. 10. I turned off all software on the PC and let it cool down for 10 minutes. 11. I recorded the thermal image and the thermocouple reading of the processor at cool down state. By following these steps, I was able to measure and compare the temperature of the Ryzen 7 7800X 3D processor under different workloads and scenarios using an infrared camera and a thermocouple probe. In the next section, I will show you the results and analysis of this experiment. In this section, we will compare the results of the infrared camera with other methods of monitoring the temperature of the Ryzen 7 7800X 3D CPU, such as software tools or thermal sensors, and discuss the advantages and disadvantages of each method. The infrared camera is a device that captures the thermal radiation emitted by an object and converts it into a visible image. The infrared camera can measure the surface temperature of the CPU without any physical contact, which can avoid interfering with the airflow or cooling system. The infrared camera can also show the temperature distribution across the CPU and identify any hotspots or uneven cooling. However, the infrared camera also has some limitations. First, it is an expensive and bulky device that requires a clear line of sight to the CPU. Second, it can only measure the surface temperature, not the internal temperature of the CPU cores. Third, it can be affected by external factors such as ambient temperature, humidity, or dust. Software tools are programs that can read the digital temperature sensors embedded in the CPU and display them on the screen. Software tools are easy to use and can provide real-time and accurate information about the core temperatures of the CPU. Software tools can also show other parameters such as clock speed, voltage, fan speed, or power consumption. However, software tools also have some drawbacks. First, they may not be compatible with all CPUs or motherboards, especially new or exotic models. Second, they may consume some CPU resources and affect performance or stability. Third, they may not be able to detect faulty or inaccurate sensors. Thermal sensors are small devices that can be attached to the CPU or its heatsink and measure the temperature by physical contact. Thermal sensors are cheap and simple to use and can provide reliable and consistent readings of the CPU temperature. Thermal sensors can also be connected to fans or alarms to control or warn about overheating. However, thermal sensors also have some disadvantages. First, they may not cover all parts of the CPU or reflect its average temperature. Second, they may interfere with the airflow or cooling system and cause additional heat or noise. Third, they may be damaged or detached by vibration or movement. As you can see, each method of monitoring the CPU temperature has its pros and cons, and none of them is perfect. Depending on your budget, preference, and purpose, you may choose one or more methods to keep an eye on your Ryzen 7 7800X 3D CPU and ensure its optimal performance and longevity.